In this video, we are going to learn how to design this box. But basically, everything what we are going to do can be applied on any kind of board. So once you learn how to do it for this RP2040 board, you can do it also for your own projects. And Jake is going to do all this step-by-step tutorial. Thank you very much, Jake, for
Yeah,
doing this, and we can start.
thank you very much, Robert. Yeah, so this is going to be a fairly simple 3D printable design. Both you and I are really big into 3D printing, and so we wanted to give this as ease of use for printing as possible, but also make it parametrically driven. So if you have to change the size or make it stronger in some way, it's as easy as possible to do. So this is going to be the final design. Uh, I like to change all the colors for all of my projects. I don't know why everyone leaves it as the default gray. It doesn't look very good. So I'm imagining that I'm going to be making this in a 3D printed green material. Therefore, we're going to be coloring it. But we're going to show you guys the entire process from making the file, importing the step, creating the entire project, and then how to export it for your 3D printer. So let's get started.
Okay. So what is the first step?
So the first step for this that I like to do is to make a folder to actually contain all of our parts. So not only do we have a file for the actual project we're looking at right now, but we also have a couple of these step files. That's the actual Raspberry Pi Pico that we have here. That needs to live somewhere. And just for organizational shape, I like to keep it in one folder. So I've got this pre-made file here. But if you want to make a new one, you can just make new folder right there. I'm just going to call it Pico. Oops. By Pico. There we go. And this is where we can actually hold our files. So I found this file for the Raspberry Pi just on GrabCAD. It's like a Google of 3D models. You can find anything on there. So you're going to be looking for a step file, not an STL. Very, very important.
Mm-hmm.
But I'm going to click this blue button right at the top, upload, select files. I'm just going to go into my downloads, and I have my step file right here.
What's
So
the
as soon as I
difference
open it,
step and STL?
so a step file is essentially made from a CAD program, from any CAD program, and you're giving it to another CAD program. So it doesn't keep all the information like the timeline of how it was made, but it keeps all the information like surfaces and color, which is really, really important, as well as all the organization as far as the components that actually make up the project. So, for example, you can see there is the main board, just like this, that doesn't have any pins, and then we have separate pins on the underside. That would be a separate component that was joined together. And this is different to something like an STL that you'd find on Thingiverse or printables, where it doesn't actually have any information. It's purely just the 3D model, where
Mm-hmm.
it's just made of
So you can't really like
millions of
hide pins
triangles.
or hide connector or something like this because there are no
Exactly. There's
objects.
none of that information. It's
Mm-hmm.
just the 3D model in as small of a package as possible.
Can we have a look inside
So
of
if
the
I'm
Raspberry Pico in the browser? I just would like to see what kind of objects is inside. No, no,
so if I
yes, there, yeah. Oh,
so if I
okay.
open this up as a separate file, you can see it's got a lot of pieces. So you
Mm-hmm.
can see every single individual
Mm-hmm.
pin is something that we can turn off and hide if we want to. All of the individual chips, I imagine, those are all individually made. So it gives you as much flexibility as you can possibly want.
Okay, step
That's
file.
the advantage of it.
Okay,
That's
important.
for a step file, yeah. It goes by STEP or STP. Those
Mm-hmm.
are exactly the same things.
Mm-hmm.
But to actually make our project, we
How
actually
did?
want to
Yeah,
make.
okay. I wanted to ask how did you import it?
Oh, yeah, go ahead. So to make our project, we're going to be starting off with a blank design. And I'm going to go ahead and save this to our folder that we just made. I'll just call this the Pico housing. Oops. Pico housing. And we can save this and you'll see that it pops up right there in our folder. Very, very important. But because we want our Raspberry Pi actually in our design, I'm going to be right-clicking it and say Insert into Current Design.
Mm-hmm.
Then it's going to be taking that information and plopping it in there. You can see on the right-hand side, it has some move capabilities. We really don't care. We're just going to say, okay, leave it in place. But right now, we can actually pick it up and move it if we want. But because we're going to be building our 3D printed object around the housing, we just want to make sure it stays in place. So I'm just going to do Control Z to get it back to its original location. But to make sure that it doesn't move, I need to do something called grounding. So I'm going to right-click my step file and click ground, and you'll see there's a little red thumbtack icon. Now if I try and click and drag it, nothing's happened. It's grounded, it's cemented in place. And now we can actually start to then make our component of our housing to build around that, which is really nice. So I'm going to go up to Assemble, New Component, click that. I want to make sure that I'm using an internal component. There is a difference between internal and external, but it's much more complicated of a topic than this video. But to just make things simple, I'm using internal because I only have a handful of components inside this project. If I was working on a much larger project that has hundreds or thousands of components, then I would want to pick external.
Internal, it means it stays inside of this file or inside.
Exactly, yeah.
Okay.
It says inside this file. If I click external, then everything that I made is not only in this assembly file, but it's also in this folder right here. But for simplicity's sake, we can just keep it in here. That's perfectly fine. So as we start to build our 3D printing housing, as a first step that's incredibly important, I want to make sure that this housing, what we're actually working on, is activated so that there is a little black dot right next to it. If you start to build this with the assembly that contains both the Raspberry Pi and our housing, if you see this black dot enabled, that's not good. So absolutely double check that you have this little black dot next to their enabled. Super duper important.
Because I think then it means everything what we are going to do right now, it will be kind of recorded under this housing part.
Exactly, yeah. We want all bit of information and geometry and dimensions to be inside the housing. I don't care if it's under the assembly. That has nothing to do with it. All the information needs to be where it is. In a similar way that if you have 1,000 photos, it's much better to put them in individual folders instead of just picking one picture out of 1,000 in one gigantic folder. So the first thing that we're going to do is make a brand new sketch. That's a 2D plane that you can put geometry on. And I'm going to be clicking on this top surface right here. And the first thing that we're going to do is actually make a bit of a standoff right here, just over the logo. So I'm going to type C for circle, and I'm just going to click anywhere near the logo. Doesn't matter whatsoever. Click once, pull away, and click again. And then I can hit escape to get rid of that circle tool. And you can see it's blue because it's undefined. It doesn't have any information about the size or the location. So I can click and drag this circle, change its size, or I can click and drag the very center and change the location. And as soon as we've locked down how large it is and where it is, then it will turn black, which means it is fully defined, which is exactly what we're looking for. So the first thing that I want to do is kind of limit the fact that it can move left and right, which I don't like. So I'm going to click the horizontal and vertical constraint, click on the center, and then click on the origin. But as you can see, it actually put a little error logo on there, which means there is something that's already constrained in the circle. And if I look, I actually clicked on this little ring of the logo. So this little icon right there, that's coincident, which means the two things are locked together. So I could remake the circle if I wanted to, or I could select that icon and click delete.
And now this happened because you just placed by accident you placed the circle exactly where the.
If I was doing this really properly, I would make a circle out there, dimension it, make sure it looks really good, and then bring it into place. But there's a pretty common expression in CAD. There's more than one way to skin a cat. There's infinite ways to make any of your designs, and as long as you get to the final location and it doesn't take you a million steps, they're all correct, basically.
But it's good to to keep it here because this may happen also other people. So it's good to know what they should do if by accident they lock something.
there is a thing in CAD programs where sneakily they will do things for you that you actually don't want. And if you don't know a lot about the program, then you're like, I don't know what I'm doing wrong. And so, yeah, so kind of showing this is fairly important. But like I said before, I want to make sure that this circle can't move left or right.
Mm-hmm.
So I'm going to add a vertical constraint between the origin and the circle.
Mm-hmm.
So I can still change the diameter and I can still move it, but only up and down.
Mm-hmm.
So to actually solidify that, I'm going to click D for dimension. Let's dimension the diameter. This is going to be 8 millimeters in diameter.
Mm-hmm.
And then the distance from the origin to the circle is going to be 16. That's going to put it right over the logo, which is really important because there's actually no super duper important fragile microchips over the logo. It's just
Mm-hmm.
printed. So if we have that as like a base to press onto, that's completely fine. And as you can see, our circle is completely black, which means it is fully defined.
Mm-hmm.
We can also double check that just to make sure everything's groovy by expanding the sketches and seeing that there is a red padlock. That's also really, really important.
Why we would like to
Um,
have it black? I know, but I think it's important to explain because when I was starting with Fusion 360, you can have everything blue, and
you can
it.
totally do it. There's certain scenarios where that's completely acceptable, but if it is undefined, it means it can move without you asking it to. And so think you may be working on a design for hours and some sketch in the very beginning that you didn't fully define changes, something moves, some dimension expands and in a way that you don't want. And then the rest of your design is kind of in limbo. You don't know where this error is. So it's really important to kind of go through and verify that all of your sketches are fully defined. These little red padlocks, you always want to see that. If you don't see that, you see a little pencil icon there, then you know something is undefined and there's something that you really need to fix.
Mhm. And I would like to point out one of the very big reasons why we would like to define everything is because we define a relationship. And if we move
Absolutely.
something, it means if there is a relationship between two objects, then other objects may move automatically without us actually moving it manually.
Yeah, which is not great. So making sure everything is as fully defined as possible is great. There is the chance that if you add too many constraints, you can actually do something called over-defined. The kind of classic example of this is if you sit in a chair with 3 legs, then it's totally stable. But if you sit in a chair with 4 legs, then it can start to wobble because there's actually too many points of contact. It's over-defined. And so in this scenario, because everything's defined, we're all good to go to proceed. So I can go ahead and finish this sketch. You will notice that I moved my view. I originally had it as a top-down view,
Mm-hmm.
but now I have what's called an isometric view, where it's kind
Mm-hmm.
of downwards, diagonal. So anytime you're going from a 2D sketch to a 3D object, really important to show off its 3D-ness.
Mm-hmm.
Super duper important. So for this, I want to extrude up this cylinder. So I'm going to click the extrude button, and I'm going to be actually turning off the Raspberry Pi. Whoops! Oh, it actually has me select all of them. Oh no, that's
Oh,
annoying.
you can show how selection works.
So as far as the profiles that we have right here, I actually want to undo that, and then I just want to click on all the profiles that make this surface. So it's quite a few, actually. Goodness me. Oh, and there's a couple little tiny ones that we don't want to miss. There we go. So if I turn the Raspberry Pi back on, one thing that I want to do is because our board is actually so tiny, if we want to mount some screws to the 4 holes on either side to really secure it into place, normally you would have some kind of tubes that go over the holes
Mounting
right here,
holes. Mm-hmm.
mounting holes essentially, but we don't really have a lot of room. This is a Pico. This is a smaller version of the Pi, much smaller than the Arduino that you've done in the past, and so actually don't have that capability. So one thing that we're going to do is actually put the mounting holes actually elevated above our Raspberry Pi, but use the the USB micro and this little cylinder as kind of a stopping point. So it allows us to screw it in place. So instead of actually bringing it up a certain dimension, I have no idea how big it is. I actually want to say that the extent type where it's ending is to an object, and I'm going to click on top of the USB-C. So that just so happens to be 2.49. I have no idea. It doesn't matter one bit to me. But to just bring it up just a little bit more, because as we all know, on micro USBs, there's that little flange
Mm-hmm.
on the end of it isn't perfectly flat. I'm going to say up to the object, and then an offset of 0.25 millimeters.
Oh,
So
I
it just
didn't
kind
know
of
you can
brings it
do
up
this.
just that.
That's cool.
Yeah, yeah. So the offset, you can say an offset from the starting point or the ending point. That's really, really useful. And then I'm just going to be clicking OK. Like I said before, I want this to be a 3D printable object. And so one of the nice things that you can do is just change the color, make it look like the final object, which is really nice to do. This default steel color is always a little bit depressing. So let's make it a fun color. So I'm going to type A for appearance. And then I'm just going to be searching green. It's got 19 in the library, so I'm just looking for like a plastic. There we go. Actually, either one of these. So I can just download this glossy green plastic, and I can drag that over to our cylinder. There we go. And if you want to change the color or anything like that, you can click and drag this grid anywhere, but I think that looks about right. I've got some green filament right here, so I've got a pretty good view. That looks about the right color. The next thing that we're going to be doing is making the surface right above that where our circles can actually screw into. So I'm going to be making a sketch on top of that cylinder. And then, really importantly, I'm going to be typing P for project, and I'm going to be selecting the holes, the 4 holes on our Raspberry Pi. These are actually big enough to have a M2 bolt pass through kind of neatly. So you can see under the geometry, it says 4 selected. So the whole point of the project is it kind of acts like a projector or a shadow, where you're taking information from a 3D object below the plane that you're working on. And as you can see, it projects it
Mm-hmm.
above onto the surface you're actually working on. So that's really nice. The other nice thing that it does for us is that it actually adds a center point to that circle. So if we have a bolt that passes through that hole really easily, we need to make a slightly smaller hole so that it actually can screw into nice and easily. So I'm going to be typing C for circle, and I'm just going to be drawing 4 circles at the center of each of the holes. And then I'm going to be holding down Control or Command and selecting the 4 circles so they're all highlighted because I want them all to be the exact same size. So I'm going to click the equal constraint right there. And there you go. So if I change the size of one of them, it changes the size of all of them. Because I'm adding a dimension to that, it's actually way faster to just change one dimension than to change 4 of them. So I said I wanted a little bit of a smaller hole in there. So the kind of classic dimension in 3D printing is that if you want a nice tight fit, you make it 0.5 millimeters smaller. But because this is actually going to be screwing into that, it's going to be carving the threads with the bolts. I can actually say that I want it to be 0.5 millimeters smaller. There we go. So now we have a much smaller hole on there.
So
I also
how
want to
did
be
you do
making...
it again? Because you use shortcuts, and I don't see. Can you use the buttons? Because
Yeah.
it's then hard
So
to see what you are doing.
that's fine. So I typed P for project. It's also at the bottom of the create menu right there. Project.
Okay, and then
I selected the holes right there.
okay, I understood the project, but how did you add the dimension?
I'll undo that really quick. So I've got my 4 circles. These are undefined. Their location is done, but the diameter isn't. So I'm actually not talking about the diameter of the circle.
You use
I'm talking about
shortcut
the
again,
distance.
no? You are in
Oh,
dimension.
excuse me. D for dimension is what I'm looking
Okay.
for. So I'm clicking on the circle and then clicking on that hole. So I'm actually looking for the difference between
Okay,
there,
okay.
not the
I
diameter of the
understand
circle
now.
itself. 0.5 millimeters. enter, and there we go. So now all the circles are in place, but now we kind of need to build the frame outside of it. So I need to make a rectangle that is nice and symmetric all the way around there. And one of the nice things about bringing in a step file is that it places it directly at the origin. So this center point right there is perfectly in the middle of our entire piece. So instead of making a rectangle from this top corner to that bottom corner, and then adding dimensions on all four sides, I can cheat a little bit and make what's called a center rectangle. So I'm going to go create rectangle and then center rectangle.
Mm-hmm.
Then I can click on the origin, pull it away, and you can see it's now totally symmetric about the origin. So I'm just going to make it a little bit larger than that. This wants to be 22 by 52 millimeters. That gives us a 1 millimeter gap all the way around. So you've got a little bit of wiggle room. So again, I'm going to be typing D for dimension, clicking this top horizontal line, bringing it up. So this wants to be 22 millimeters. Make that a little bit tall just so you can see it. And then again, typing D, clicking that right vertical line, bring it over. This wants to be 52 millimeters. So you can see that it is, I've got just a little bit of wiggle room all the way around my object. So that's great. But one thing that we do have, if I go back to the pre-made model, is that we need to have a wall thickness right here. And this is where we can introduce a really, really fantastic concept called parametric design. The idea is that you can make a model and then you can have some dimensions be parameters that you can change later down the line. So for example, if I wanted this to print pretty strongly, then I would want to make the thickness of this wall right here actually be a value that can be changed. So if I want to make it, if we're 3D printing, my most common wall thickness that I have is 4 layers, so 1.6 millimeters from a 0.4 millimeter nozzle. If I wanted this to print, really, really quickly, I may change that to just 0.4. So it's just one wall. It's not very strong, but it'll print pretty quick. So if I go back to my project, I'm actually going to make a bit of a frame, another center rectangle all the way around it. So I'm going to go rectangle, center rectangle. Again, click at the origin, pull it outside of our previous rectangle, and then I can actually define what is that parameter. And there's 2 ways to do it, and I'm going to show you the much faster way to do it. So the traditional way is that you go into this tool called Change Parameters, and it brings up this little pop-up, and you can then say, I would like to make a new one. Okay, what's its name? What's its size? What's its unit, etc., etc. But a much faster way is to actually make that parameter inside of your dimension tool, which is really, really quick. So I'm going to type D for dimension. I'm going to say the thickness of that wall, so the distance from those two. When I click that, I'm actually going to be typing thickness equals 1.6 and then hit enter. So now that value is represented as a parameter. So if I go back and open up my parameters, you can see the name is thickness, it's in millimeters, and it's 1.6. And I'll as soon as we actually make it into 3D, we'll be messing around with all these values. In a similar way, now that's actually a shortcut. So I know that the distance between, if I type dimension again, the distance between that horizontal line and that horizontal line should also be that thickness. So instead of typing thickness equals 1.6, it's actually already made. So I can just type T, and it goes, I bet you want a thickness. And go, yeah, I do. Hit enter, and it's done. So it's always based off of that numerical value that we made, which is really, really handy. But now I'm going to be finishing this sketch, and I'm going to be extruding that frame, that's the inner box, this circle, and a couple others just to make that thick platform that we can actually screw our bolts into. So I'm going to be typing E for extrude. I'm going to be clicking the frame, that inner rectangle, these outer kind of donut rings. And don't forget the actual circle itself. And because we want a good enough thickness for our bolts to actually screw it into, I'm going to make it fairly thick at 3 millimeters. And then click OK. And what I want you guys to notice is that even though we just made that 2D sketch, it's actually disappeared into that. So we will be working that again. So don't forget about it. But we actually don't want to have holes in our 3D printed enclosure for an electronics project. Not the best idea. So I'm going to be capping this off. But one of the things that a lot of people forget is that they go, okay, well, we'll make the top 1 millimeter to kind of seal it off. That's fine. I can select that surface to make it 1 millimeter. That's fine. But then you can't click on the holes because they're a void. They don't actually exist. They're a negative bit of material. So what we have to do is make a sketch on that top surface and type P for project, click that surface, and then click OK. What it's done is that it's now given us that circular profile that we can now select, which is really, really handy. So if I finish that sketch and then go back to my extrude tool, not only can I click this surface, but I can now also click these holes as well. They're now no longer a negative space. There is a circle on that surface, and that allows us to extrude it 1 millimeter and click OK. So now that top surface is totally sealed. So we're all good on that. What I was saying earlier is that our little frame piece has actually disappeared. And it hasn't been completely erased. It still exists, but we need to hunt for it. So it is in the sketches. You can see our original sketch. If I click this little eyeball icon, that circle has popped up. That's not what we're looking for. The second sketch, sketch 2, this is where we have that frame. That's what we're looking for. So I'm going to be extruding that surface down a little bit. And that's also something that we're going to be making parametrically. So I can click on this outer frame, and I'm going to be typing depth equals -15. It's negative because it's actually going downwards. That's really important. And I chose -15 just because that gives us just a little bit of room between the top of those pins and the surface. So if you need to put some wires in there, you need to solder to it, it just gives you a little bit of headroom. But the kind of perfect reason that you work with parameters is that if you go, I actually don't need it to be that thick, or I want it to be even deeper, you can change that parameter. So if you want it to be -30, so twice as thick, as soon as I hit enter, it's now increased that value automatically. I haven't changed a thing. If I wanted to really make the walls super duper thick, so 5 millimeters, I can do that as well. And it updates the model automatically for me. I haven't had to change a thing inside the model. This is really handy if you're giving this file to someone else. If you and a buddy are working on a project, you are now simplifying all the things that you can change in your model. So this really works fantastically for like woodworking projects. If you're designing something like a cabinet that has to be, fit into some corridor, and you don't know how big it is, you can just set it as a variable, and then you can measure it in real life and then update your model. So it's a really, really fantastic way to kind of design. It's a little bit of a different thinking. But we now no longer need that sketch, so I can go back to that eye and turn it off. So now we've kind of got this random blocky 3D print. All right, next we are going to be cutting out the little slot for our USB micro to actually be accessible. So I'm going to be making a new sketch on that surface right there. And to make the actual cutout, I'm going to be using a tool called slot. So if I go into create, go to slot, I'm going to be clicking center to center slot. Or I could also click center point slot. Both of those will work. I'm going to click the kind of most common standard one. And I'm just going to be making a horizontal slot just so it's in the right location, so we have enough room to actually plug something into it. So I'm going to be adding a central point to this horizontal line because I want it to be perfectly centered right above the origin. So it's a little hard to see, but there's a little X right where my cursor is when I put it on that line. And as soon as I move my cursor to the exact middle of this dashed orange line, it'll show up with a triangle. There it is. That means that it is the midpoint of that line. So if I click there, and hit escape to get rid of the point tool. This is still undefined, by the way. I can now use the horizontal vertical constraint to then click on the origin and that point, and that means that it cannot move left and right. We can only move it up and down. So that makes it much easier to work with. So now let's add on some dimensions onto this. So I would like the height of this gap to be 3 millimeters. So I just typed D for dimension, click that top line, click that bottom line, move it over, click again. We'll say this is 3 millimeters. The width of this center line, I would like that to be 8 millimeters. And then just so you guys know, the open side is on the top because that is, or this surface is a variable that will change in height based on the parameters that you do. I actually want to define the center point to the bottom surface because that's kind of our datum. That's the unchanging point. So I'm going to say that this is 5.5 millimeters. There we go. And then I can finish my sketch. So now I can actually extrude this slot through our piece, and that should line up perfectly with our micro USB. So I'm going to type E for extrude, or I can click this icon in the top corner. Doesn't matter. Click that surface, and I'm actually going to type in negative thickness. And the reason for that is because the thickness is obviously parametrically driven. If I type in negative 1.6, but then I change my wall thickness, that now changes everything. So I'll enter that, cut it in, and our USB micro is now perfectly centered in there, so you can always access it, which is fantastic. One thing you should know is that if you do want to make this for your own project, and you have one of those really chunky micro USB cables, you may have to go back and change that slot diameter to kind of accommodate that. So if you do need to do that, you can go down to the bottom to our timeline, and you can see that we have our most recent extrusion right there. And just before it, we have the sketch that defined our slot shape. So I can double click that to kind of roll back the clock to bring us back to that sketch. And if you go, oh, the width actually needed to be 10 millimeters, for example, that's where you can do it and then finish that sketch. And now you're back to the present after you've made that cut.
This is like super useful feature. I would like to say when I was starting with Fusion 360, I had no idea you can do this. And I always like just continued. If I needed to make change, I just made a change later and it was mess.
It's super common. Yeah. So there's a lot of really good ways to do it. What I just did where you double click on the icon to go back to that position. The other way is that you just right click on that icon and you can say edit sketch. So the exact same way, but this timeline is super duper useful. This little black bar, kind of a playhead on a video. You can actually click and drag it and rewind your entire project so you can see all the steps that went into it. So if I'm ever working on a design that somebody else has given me, the first thing that I'll do is actually scan through the timeline so I can kind of get into the head of where they are in the design and what they've thought through as they're actually building it. Fantastic. All right. The next step that we want to do is building on a little bit more geometry on either side so we can build in some mounting hardware. So I'm kind of assuming that if you've got some M2 screws to secure the Pico to this 3D printed housing, then you may have some M3 bolts that you can secure this to a wall or a housing lid, anything like that. So I'm going to be building just one of them over here and then patterning it over to the other side over there. So the first thing I'll do is make a new sketch, and I'm going to be making it on this frame right there. I'm going to be making 2 concentric circles. So co meaning 2, centric, center. So it's 2 things that share the same center. So I can click anywhere over here, pull away, click again to define that circle, and then I'm going to be clicking on the center of that circle again and pulling away and clicking again. So you can see I've got this kind of 2 circles in one another. That's concentric. That's the same icon right there. So now I can go ahead and define these now. So I'm going to be typing D for dimension, clicking that inner hole, moving my cursor away, clicking again, And I'm going to be parametrically defining this as hole, and we'll say that this is 3.5 millimeters. There we go. And then moving that out of the way. Now that I can define the outer circle on that, I'll just say that it's the exact same number as that. So I'm going to go D for dimension, clicking the outer circle, then the inner circle, and you can do that either way, it doesn't matter. And I'm going to be defining that as the same value. So I'll type H, which will bring up the hole parameter. And that gives me a really large amount of material that makes a really strong holding, essentially. That's great. Then I can say the distance from the center of the circle to the origin. I want that to be exactly 20 millimeters above. What you'll notice is, depending on where I put my mouse, that changes the distance that it's actually measuring. So if I put it over to the left, it's measuring the height, which is what I want. If you move it kind of to the middle, it's showing kind of the hypotenuse. It's the shortest distance between it. If I move it above, it's showing me the left to right distance. So depending on where you put your mouse, definitely makes a difference. So I'm going to be moving it over here and say that is 20 millimeters above. I want to make this outer circle right there actually touch this outer wall. So that would be a tangent connection. Tangency just means that I have a line or a circle or an arc touching another circle at just one point. So I can click the tangent constraints. I'm going to be clicking that circle, clicking that outer wall, and there you go, it's touching at one point. And because we've now defined the circle and the location or the dimensions, that is now fully defined. That's great. But one thing that I want to do is, if I'm going to be extruding this, it's obviously not really touching the rest of my housing very much at all. And so I'm actually going to be kind of drawing a bit of a triangle shape on either side, just to make it that little bit stronger. So I'm going to be typing L for line, and I'm going to be clicking on this outer corner. You can see it draws a little square that's a snapping point. And then I'm going to be touching my line to that circle, but I'm actually going to be tracing my cursor along that arc until I see the tangent constraint. What we talked about earlier, where Fusion will add constraints for you. This is a scenario where instead of making a line and then adding a tangent and putting it on there and having all those extra steps, it can actually do it for me, which is much nicer. So as I move my cursor, I'm waiting for that tangent icon to pop up. Oops. There it is. So I can click there, and it has automatically added that tangent constraint. That's really great. But if I want to do the same thing over here, I actually have a little bit of a dilemma because, well, I started on that corner, but where is my starting point over here? I'll do it really comically. I'll start all the way down here, and again, I'll trace along my circle until I get that tangent point right there. This is still tangent, but obviously this is blue. It's undefined. So I could click and drag that circle to any size, and that's not what I want. I'm always looking for a little bit of symmetry to make the design look nice. So I'm going to click on the equal constraints, and I'm going to select my define line, and then my undefined line. There we go. They're the same length. I don't care about the angle because I've already defined that with this top line. So that's great. So now everything in my sketch is fully defined. I've got that red padlock. So I can now finish this sketch, get a three-dimensional view. Very, very, very important. Then I'm going to type E for extrude, and I'm going to be selecting these three icons. You can see that the arrow is pointing down. That is now the positive direction. So if I want it to go upwards, I have to type negative, and I'm just basing it all around that whole dimension. So I'm just going to type H for hole. So now everything about it.
So bigger screw, everything is automatically bigger.
Exactly. If I go, I actually need like an M8 bolt, something huge, then the entire mounting bracket automatically becomes beefier, you know? Or if it's, oh, I just want an M2 bolt, just needs to be kind of small, then everything shrinks down accordingly. And it's all based on one parameter. So defining that very early on, it means if I ever need to change this file, it's massively easier. So I can click OK. But as you can imagine, just one mounting hole isn't actually all that strong. And so I do actually want one on the other side. Now, if you wanted to use the mirror tool, you could put this mounting bracket over there. I'll actually do that really quickly. So if you want both of your mounting brackets to be on the same side, if I want it over there, then my object type is actually going to be the features. I'm going to go back down to my timeline, click on that most recent extrusion, my mirror plane. I don't know if you can see it. There we go. These are our original planes that are popping up. So if I click my front plane right there, you can see a little preview to that side. If I want it to be on the opposite side, I can click on my right plane right there. So it's popping a preview over there. But what happens if you want it in this corner over there? Well, that's when we can actually go back to being lazy and say that when we imported the step file, it put it at the origin. So instead of actually using a pattern tool, I'm actually going to be using a circular pattern tool. I'm going to be revolving it around
Instead
that
of
origin
using the
to be
mirror
placed on the
tool.
other side. Not using the mirror tool.
Yeah.
Because I want it to be on the
I think you say
diagonal side.
pattern tool. Before it was the mirror tool. What do you? Okay.
Mirror tool is if you want it to be on this side or on this side, but if you want it to be diagonal, then I want to use the circular pattern tool.
Okay, I understand.
So I'm going to go create pattern and then circular pattern. Again, it's asking me, what do you want? Pattern? Well, I actually want the feature because I don't want to pattern the entire thing. I just want that most recent extrusion.
This is super useful.
Kind of making...
like using
super
features, it's super useful.
Yeah. So in this object type, you can say the bodies, well, I actually don't want that because that's my entire project. The components, again, I only have one 3D object, so that would mean the same thing. I could have clicked faces and then selected all of the faces that makes up this thing, but as you can imagine, that gets kind of annoying pretty quickly, especially when you have a really complicated model. So I can change that back to features, click on that most recent extrusion, that's great. And then the axis is going to be the vertical z-axis. As you can see here, the blue one, it's a little bit hard to see.
Yeah, I can see.
That's coming directly above the origin. And when you do this, it's automatically going to set a quantity of 3, which although doesn't look great. But if I change this to 2, then you can see it's patterned it around the origin to be placed on the other side. So because we made everything about the origin, and because we used that center rectangle, so everything is nice and symmetric from it, it means that this is already in the right location. So I can just click OK, and I have 2 mounting holes diagonally across from each other, and I've only had to make just 1. So massively useful. The other thing that we actually want to do is to add on a little bit of a hole for that LED to kind of show through. If I turn off this housing, if I click the little eye icon next to it, this little brick right here, that is the LED. It's absolutely tiny, but it does have the text on the pie on there. So what I want to do is take that information that's below my object and actually bring it up. So that's going to be using the project tool. So I'm going to turn back on the housing. And you have a really, really cool trick. Instead of just having a cutout, which would obviously mean that moisture or any dust can get in there, but we're actually going to be making a circle that's 1.75 millimeters in diameter. That's the same as 3D printing filament. So if you print that whole size, you can then jam in a clear bit of PETG, and it kind of acts as a window, which is absolutely genius. That I've never thought of that before. That's fantastic. But because we want to make sure that it's in the right location, I'm actually going to be making that circle on the top point. So let's make a new sketch on this top plane. I can turn off my housing. This is my LED right there. So I'm going to type P for project. Click this little rectangle. Click OK. Turn back on my housing. You can ignore that little warning. And now that is the shape of the LED, but just raised onto our surface. So if I want to put a circle at the very center of that, you'll notice that there isn't any points.
I'm curious how you are going to
do
this. I'm very curious.
So I'm going to use diagonal lines. So I'm going to type L for line. I'm going to click that point and then that point. And just with geometry, I know that the midpoint of that line is the dead center of the entire rectangle, which is really handy. The other thing that I'm going to do, which is going to make our lives a lot easier, is I'm going to say that this line is the construction line. So at the end of this sketch, all I'm looking for is a circle that's a certain size in a certain location. I do not care about this rectangle, and I don't care about this line. It's only using me to help make that circle.
Mm-hmm.
So I'm going to be clicking this line so it turns blue and typing X. That makes it into a construction line.
Mm-hmm.
I'll see if I can do the same thing for the project. Sometimes it works, sometimes it doesn't. There we go. So this is now turning into a dashed line. What this does is that if I want to extrude anything on this surface, like the circle, it's going to be ignoring those lines because they're a construction. They're only used to help you build what you actually have.
So it's not going to
I'm going to
break
type...
the circle into
No,
multiple pieces.
not at all. If you're making a structure and you have scaffolding, it's just that scaffolding is not the final project. It's just you're just helping you to make the final thing.
Mm-hmm.
So I'm going to type C for circle. And again, where I'm going to be using the idea that Fusion will put certain geometries for me. So I'm going to be scanning along that line until I see the triangle. But I can't really tell. That green and that blue are pretty close. So instead, I'm going to click anywhere on that line, pull away. I can type 1.75 for the diameter. Click OK. And then I'm going to be using the midpoint constraints. So I'm going to be clicking the center of that circle and then the line. And there you go. It's going to be snapping then to the center of that point. Then I can click Finish Sketch because I'm all done with it. Oops. Get a good view of it. Then I'm going to type E for Extrude. And now you can see that I can select the entire circle. It's completely ignoring the rest of those lines. I know that we had 3 millimeters and then 1 millimeter to make the top of that housing. So I'm just going to be typing -4 to cut downwards. You can see that it's actually a red cutout, and my operation is set to cut, which is great because I've got an interference. And then I can just click OK. And now you can see, if I have a head down shot, that my LED is directly in the middle. That's perfect. Great. So now, one thing that I want to do is I'm seeing a lot of sharp lines all over the entire model, and I want to kind of get rid of that. So I'm going to be adding some fillets onto the entire thing. And the fillet tool is right here in the modify menu. It's essentially just knocking off the corners, adding a little bit of a radii onto it, and it makes for a nicer print. It gives it better print quality. It makes it slightly stronger. It's nicer to hold. It'll last longer as well. And it's less likely to pick up dirt as well, because 3D prints with the layer lines, they love to grab onto little particles on there. I don't want to add any fillets onto the Pico, so I can turn that off. Then I'm going to click on fillets, make sure it's not pronounced fillet. Then I can click one corner, click and drag, so I can highlight the entire thing. Then I can add on a fillet. Some people, they actually may accidentally have freeform selection. So when they try and click and drag, they're actually drawing this weird funky shape. So that's right here in this top corner. The select, you just want to make sure it's set to window select. Whoops, let's go back to fillet. Click and drag, highlight the whole thing. And then all it's asking for is a radius, essentially. So if I go down really small, like 0.1 millimeters, it's adding on this absolutely infinitesimally small fillets. But if I go too large, if I say 2 millimeters, it's going to give me an error saying that I physically can't have that much of a radius on there. And so what I'm going to be doing is actually typing in 0.5. That is a large enough of a fillet where it's going to be noticeable on the 3D print, but not so small, or not so small where you can't see it, but not so large where it's going to give you errors. Then I can click OK, and now all of my sharp corners are now perfectly smooth, which is exactly what I'm looking for. It means it's easier to assemble as well, because we don't have this kind of perfect sharp hole to put our bolts in there, it's acting a little bit like a countersink, where it's actually easier to assemble. So it looks nicer, better for you. It's just the best. I love fillets. And then as a bit of a finisher, because this is a slightly boring box, I want to put the Raspberry Pi logo on the top. So one thing that I feel like I'm on a cooking show. One thing I've assembled earlier is I've actually built what's called an SVG. That stands for Scalable Vector Graphic. There's lots of free websites where you can take any image that you want. They're usually called SVG generators. Plug in an image, and it essentially traces the outline of all of it. And it means you can place it onto your model and scale it to be whatever size that you want, and then you can extrude it if you'd like. So I'm going to put it on this top right here. So I'm going to make a new sketch on this top surface. Then I'm going to go into Insert. I actually have the shortcut right there. But you can go Insert and then Insert SVG. It's asking you, where is it on your computer? I've already downloaded it. Right there, it's grayed out everything else. I'm looking for the SVG. I'm actually going to give this file, so you can put it in the description below. We can click Open, and then it's usually absolutely massive. So the first thing we're going to do is click this little water circle. I can drag that down so it's much smaller. And we'll just kind of play around with the scaling. So centralized, that looks pretty good. Then we can click OK, and that will now place that SVG. So it's exactly like making a sketch on a plane. It's the exact same thing. But instead of drawing lines and slots and circles and arcs, it's taking all that mathematical curvature from that image and just making it up in
I
CAD,
didn't know this
which
is
is
good
really
tip.
handy. This is phenomenal. If you ever building something for a client, putting their logo on it makes all the difference. They
Next time I will
get
use
so
it.
excited.
Next time I will place
Yes.
my logo on some
Yeah.
boxes.
So I finished that sketch. Now I've got an enclosed profile because it's highlighting in blue that I can now extrude upwards. So I can select that, say 1 millimeter,
It's better
and
put
there you
it
go.
up or down for 3D printing.
For 3D printing, it depends. So if I'm printing it in this orientation, where this surface is my build plate, and I'm adding a bunch of supports in there, then I would want to extrude it upwards. But if I want this surface to be on my build plate, which means I don't need to put any support material in there whatsoever, then I can actually change that. So
you would need, because there are these
oh yes, you would need,
eaves.
but you wouldn't need anywhere near as much.
Mhm.
So it's just different. So if you want to have all of your ugly surface that you get from support material,
Oh yeah.
if you want that to be hidden and on the inside where nobody's going to see, that's great. But if you want to have a faster print time and a better quality, then you can print this to be the flat surface. So you can do it either way. So if I want to make this a recessed logo instead of a proud logo, I can right click or double click, doesn't make a difference, to say edit that feature. And then say instead of 1, I'm going to type -1.
Mm-hmm.
And instead of join, I'm going to change this to cut.
Mm-hmm.
So it's actually removing some material. And there you go. So it's incredibly easy to edit anything about your design to be exactly what you want.
I think the
And
opening
as
for
soon
the
as you,
USB connector is maybe a little too big, because we made it 10.
Oh, that's right. We made it 8 millimeters. So I'm actually going to scroll back through my timeline to see exactly where I made that slot. Or I can actually click on any of the surfaces of my slot, and you can see in my timeline it's actually added those 3 angled lines. So I know the sketch just before it defined that. So I think we said we actually want it to be 8 millimeters. So I can double click that, type 8, hit enter, and there you go. Then I can move back my timeline all the way to the beginning, or all the way to the present. And it's now taken that change and pulled it all the way along to the present. And this is a 3D printable project. So I'm going to show you one of the best tips in Fusion 360. I want to export this as an STL, a stereolithography file, so that I can 3D print it.
There is one more thing we maybe wanted to do also the back.
Oh, yes, that's right. So we can also add on a back. So what I'm going to do is use our project tool again, but I'm actually going to be doing that before we add on our fillets. Then we've got all these nice and easy sharp corners. So if you wanted to add on the backing to this, if you don't want to secure this to a surface, then I'm going to be making another component on this, or another body. So I'm going to be activating the entire project, the assembly at the very top. Then I'm going to be saying new components. Then I can say backing, for example. Again, I'm going to make sure this is an internal component, so it lives inside our folder. Click OK. I'll click bottom on our view cube so we get a nice, neat view of it. I'm going to be making a new sketch on the bottom of our housing, typing P for project. Then I can click anywhere on the surface. You can see it's outlining in red my entire profile. I can click OK. But because this hole right here, this is a through hole for an M3 bolt. And if I want to make that just a little bit smaller so you can actually screw it into there, then just like we did earlier, I'm going to click C for circle, click the center of the projected point, and then make a circle. Same thing on the other side. I can click the equal constraint, select that circle, select that circle. So now they're both exactly the same size. And then I will say that this is, or the distance from that circle to the through hole, we'll say that's 0.5 millimeters. I'm sure you can do some tests to make sure that's as good a fit as possible. And then we can finish that sketch and then type E for extrude. Select the outer frame, and then those two little rings, and the inner profile, because we want to encapsulate our entire project. And then we can give it any thickness that we want. 4 millimeters seems nice and chunky. It gives us a good amount of, well, a good amount of material for our bolts to kind of really dig into. Click OK. I can keep this as a different color. And if I go back and activate the entire assembly, then you can see that I can fully bring back all of the fillets and the extrusion for that. And you can do the same thing for this bottom part. You can hide the top housing. You can click on fillets. You can highlight the entire thing. I think we said 0.5 millimeters. And you've then added on that fillet.
Or we can,
because it's a separate component,
I believe also we can go back in timeline and modify the selection.
Exactly.
Mm-hmm.
Because we made it as two separate components, we can actually add different fillets to different parts. We can change them as different entities, which is really, really handy. But now I've got two separate components for the housing and for the backing. So I've got two things that I would like to export for a 3D print. So a lot of people, and I guarantee some people out there, when they have a file that they want to export, they will go File, Export. And some people will say, yeah, that's how I do it.
That's
and it
how
takes
I do
100 years. Don't ever do this. What that does is that it saves the STL to your local drive, and it saves it to your cloud account. Saving it to your local is really snappy. This is only a few megabytes. But sending it to the cloud takes 1 billion years. The much faster way to do it is to right-click on any of the components. And I'm going to say, Save as Mesh.
Mm-hmm.
As soon as I do this, it's now saving it as a mesh. So I've selected an STL binary. That's the most common one. You can preview what this mesh will look like. So these are all the little triangles that make up our 3D object. It's currently set to a medium refinement. So if we want the file size to be smaller, we can select that to a lower refinement. So it's a little bit more of a simplified model. For some reason, if you want it to be super duper accurate, you can select this to a high refinement. But this is a 3D print. It doesn't have enough resolution to do that anyway. So we may as well keep it as medium. And then as soon as we click OK, it's going to save that to our local file, to our local drive. And it's instantaneous. It doesn't take 20 minutes to export a simple file. And even better, if you plan on 3D printing this with Cura or Prusa Slicer, and you don't have that program already opened, you can check send to 3D print utility. I've got Cura already set, which means when I export this, not only does it save it as my file, but it opens up Cura and loads the model inside it all at once.
Cool.
So it is
I always do everything
total.
manually.
I know this is total efficiency. This is one of my favorite bits. All right, that is going to be it for this project. I hope you guys learned lots.
Thank you so much, Jake. Only what is left.
You are very welcome.
I'm going to try to 3D print it. So when
I
we
can't wait.
when we finish this video, I can show it like it really works what we designed. So please send me the files then, or share the project. Then I can also add links under the video. So if anyone would like to try it, they can do it. Or I think you may place it also on some platforms. You mentioned you have
absolutely. I'll go ahead and share the STL with you. So I'll put it on our printables page or our Thingiverse page. So if you don't want to go through the whole hassle of downloading it or actually making it yourself, you can just go ahead and download it straight away.
Okay. So what do you actually do?
So if I want to save this,
I know. I mean, what do you do? What is your job? Or when?
Oh, what do I do? I'm the co-founder of cadclass.org. We're a company who tries to teach people how to use CAD programs in completely different ways that most people try to learn it. I have a background of being a maker, of being a woodworker and a metal worker, and a 3D printing nerd. And every single time that I would try to learn a CAD program, either from my university or from a book or from YouTube videos, all of the projects would be fantastically uninteresting, not engaging at all, and it made it no fun to learn, and I didn't actually retain anything very well. And so we're a company that is completely dedicated to flipping that script and kind of leaning into the fact that people are makers. We like to 3D print stuff. We like to laser cut and CNC. So all of our projects will teach you how to learn Fusion 360, Onshape, Tinkercad, with actually genuinely interesting projects. We also have links to courses and books as well.
Do you have a website?
You can find this. Yes, we do. cadclass.org. And if you want to pick up our book, Mastering Fusion 360, it is on Amazon. We give the entire thing in its entirety away for free on our website, completely for free.
Really?
So if you're a teacher and you want to download it and print a bunch out to your students, give it away. It is all completely free. My business partner likes learning off of online PDFs and YouTube. I'm a little bit old school. I much prefer to actually have a physical book that I can hold in my hand and flick through the pages. So if you don't want to buy the book, that's completely fine. Download it, make all the projects, join our Discord link, and show us what you make. What we love to see.
So show the Discord link and your website so everyone can find you easily.
So
CAD
this
class.
is our
Okay,
Discord
CAD class. Okay, perfect.
CAD class right there. So we've got huge amount of communities of people that just make all kinds of just ridiculously fun, wacky stuff that they've built purely on Fusion 360, learning through us. So we've got a guy who's making an automatic ping pong ball launcher just because he wanted to. We've got a kid who is 16 years old. I'll try and find it. Who is making an electric guitar, or who actually made it, 3D printed it from scratch. And he's been learning CAD for a couple months, and he designed this. So super duper fun community. If you have any questions on any of the projects that we have in our course or in our book, each one of them has its own Discord link, so you can ask direct questions.
Show also your website, because you only quickly jump through your website. So what do you have here?
If you want to check us out, we are at cadclass.org. So we do courses in learning Fusion 360, Onshape, which is coming very, very soon, as well as Tinkercad, which is coming very, very soon as well. If you want to learn more about 3D printing, calibrating and maintaining your printer, learning way more in depth about Cura or any slicing programs, we've got all courses about that. If you want to go ahead and download our book for free, you can go into the book section where you can download the entire 400-page PDF completely for free. And we
Wow.
update it regularly with all of the Fusion 360 updates that come out and with all the suggestions from our community. And we're coming out with edition 2 next summer as well. And it's really great because we only published this book half a year ago, and we've got a fantastically big community that are just showing off all the great things that they're making, and it's what we really love to see. So in our next edition of the book, we are going to be filling it with all of our students' projects, just showing them off to the world.
Cool.
So because we love to see it.
Cool. Thank you so much, Jake. So I really
You're very, very welcome.
hope everyone who would like to create an enclosure or box for their boards, they now have the idea how they can do it in Fusion 360. It's simple,
Absolutely.
it's quick, and definitely I recommend everyone to, if they haven't started yet, they should try 3D printing
Today's
because
the
it's
day.
super useful.
Yeah.
Okay, thank you very much, Jake, again, and
Thank you very much, Robert.
yeah, thank you. And that's everything. Thank you very much for watching this video. By the way, we are preparing some very interesting tutorials, so if you don't want to miss them, hit the subscribe button. If you want, you can also check out our Fedevel online courses, where you will find everything important from basic board design up to advanced hardware design and PCB layout. The link is in the description. That's all for this video. Thank you again. Don't forget to leave your comments and see you next time. Bye.